video we are going to see a problem based on engineering curve. For that, here is the question. An inelastic string 150 mm long has its one end attached to the circumference of a circular disc of 40 mm diameter. Draw a curve traced out by the other end of the string when it is completely wound around the disc, keeping the string always tight. Name the curve. Also draw a tangent and a normal to the curve through a point. So this is the question in front of us. Now here I'll explain how to draw the curve. It is given that name the curve. See, whenever an inelastic string is wound around the disc, in that case the curve which we are getting, that will be called as an involute. So we have to draw that involute. Diameter is 40 mm. I'll start here. So radius is 20 mm. Drawing a circle through this center and radius. Then I'll divide this circle into 12 equal parts, taking each angle as 30 degree. Drawing light lines. Here I'll give the notations. Then through this point 12, here I'll draw light horizontal line. Next, in this case, first of all, we need to calculate the circumference. So I can say that therefore circumference is pi d, which is pi into 40. The answer is 125.66 mm. I'll mark this distance over this horizontal line. Close to 126 mm. Then I'll divide this into 12 equal parts. For that, since it is a decimal number, here I'll divide it into 12 equal parts by taking an acute angle between 15 to 20 degree. I'm taking it as 20. Then after this, I'll measure 1 centimeter in the compass. I'll go on marking the distances here. That is, I want 12 divisions here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. As the circle has been divided into 12 equal parts, even the circumference would be divided into 12 equal parts. Then I'll give the same notations here. Point 1, 2, 3 and in order. Now in this case, if the length of the string is not given, we can start with point 12, or in other words I can say that when this involute would be complete, it will come back at this point, that is starting with 1, it will end on 12. Now in this case, the length of the string is given. When I look into the question, an inelastic string of 150 mm long. So now what is happening is the circumference which is equal to 125.66 mm, is less than the inelastic string, which is of 150 mm long. So here what will happen is the string will wound this circle beyond point 12. So for that, now I'll measure 150 mm from point 12, and here this is 150, means this will give me the point P. And next, as I see here, this point P is going beyond 12, so what I can do here is get extra divisions so that I know the location of point P, that is it lies in between which points. So here I am taking the distance from 11 to 12. I can take any one of the division and continue with the marking. So here this is 13, 14 and 15. So when I see here point P is coming in between 14 and 15, and this the points on the circle end on 12, so point number 1 I can take it as 13, point 2 that will be 14, and 3 will be 15. So point P, it is from 15 towards 14. I'll mark it here, that is keeping on 15, measuring up to point P. So marking from 15 towards 14. So this is the point P, that is, I'll say from here the point will start unwinding. So for this what I can do here is, after getting point P, I'll draw the tangent from point 14, measuring this. Next, the distance between P and 14, it is very less. I'll get this distance from P to 14 and mark it on this tangent which I had drawn from 14. So here is the point. Next, after 14, I'll draw the tangent from 13, which is at this location. So for that, drawing a tangent from P to 13, I'll take this distance, keeping it on 13. So after 13, here there is point 12 and the tangent is already there. So I'll take the distance from P to 12, keeping it on 12, marking it over here. Then the tangent to point 11, then P to 11, keeping it on 11, getting this point. Then after this, keeping it on point 10, measuring from P to 10. Next, drawing a tangent through point 9. Next, P to 9, keeping on 9. Then point 8, measuring from P to 8, cutting it by keeping it on point 8. This method is really easy. Next, marking it through point 7, that is drawing the tangent here. Then P to 7, cutting this. Then drawing a tangent from point 6. It will be a horizontal line. Measuring from P to 6. Then tangent through point 5. From P to 5. Next, tangent through point 4. Measuring from P to 4. Drawing tangent through point 3. Measuring P to 3. Drawing tangent through point 2. It is already here, which is the same point as 14. So measuring P to 2. Keeping it on 2. Here I'm drawing an arc. Extending this tangent. So here I get this point. Next, drawing tangent through point 1, which is also here, the same tangent, which was for 13. Measuring the radius from 1 to P. Cutting it by keeping it on point 1. And at last, it will be connected to point P, that is at 12. Now I'll just connect all these points in proper sequence so that we get the involute here. First draw it light, then you can make it dark. This I can just slightly draw it freehand. 12 it was cutting here. So joining those points in proper sequence. Next, making all these points dark. Then I'll make this circle dark. Then drawing the center lines. Here in this question, it was given that name the curve. So here I'll say that therefore the curve is an involute. That is the answer. After that, it was also given, also draw a tangent and normal to the curve through a point. So how to do that? Here in this case, I'm having this tangent which is in contact with the circle. So this I'll treat it as a normal, and here I'll draw the tangent through this particular point. You can take any of the points here on the curve. So plotting a parallel line so that I get a tangent here. And this will be the normal. So this is the tangent to the curve, and here is the normal. Tangent and normal. Here I'll say this is point M. I'll give the notations to this involute as well. P, after P, this is point A. Here it is B, C, then it is D, E in order. M already given. And this is finally the point P. So here I have completed this involute. At last I'm giving the dimensions here. So this is pi d is equal to 125.66, and this length is length of the string 150 mm. Then the diameter for this circle, which is 40 mm, and with this the problem gets completed.